Hello all, welcome back. We'll try to understand what is retransmission time out, that is RTO. Then RTO is time for which the sender will wait for the next segment to be sent. Then if the sender receives an acknowledgement before the RTO, then the timer is stopped and again it is restarted. Means what? If the sender receives an acknowledgement for the previous data that has been sent, then the RTO will stop and again it will restart when the next data will be sent. Then there is a second case where the sender does not receive an acknowledgement at all. So it will try to go for the whole time for which it has to wait, and once the timer is out, once the timer expires for which it has been set, then it again retransmits the segment and reset the timing. Because once the segment is transmitted, then again it resets the timing and it will wait for the acknowledgement for the new RTO or the retransmission time out. Here is an example that has been shown that the sender is trying to send a data to the receiver, and somewhere on the way it is lost. The segment is lost. Then the RTO is started immediately once the segment is sent. Then there is no acknowledgement. If we can say that because the segment is not received by the receiver, then there is no acknowledgement that has to be sent by the receiver to the sender. So it will wait for the time which has been allotted as RTO, that is retransmission timeout, and then after that immediately it will resend or retransmit the same segment. So retransmission occurs after RTO expiry. So it will wait for that particular time. If any acknowledgement is not received, then again it will initiate the retransmission. Retransmission can also occur after 3 duplicate acknowledgements. So there are 2 ways. One is the RTO and the second one is after receiving the 3 duplicate acknowledgements. Suppose if the sender receives 3 duplicate acknowledgements for the same segment sent, means if you have sent a segment and the sender will receive 3 duplicate acknowledgements from the receiver, then the sender assumes that the corresponding segment is lost somewhere. Means you have sent a segment but it has been lost somewhere, and 3 duplicate acknowledgements of the previous sent segment is continuously received by the sender. Then the sender assumes that the corresponding segment is somewhere lost. Then sender initiates the retransmission, that is the same segment is immediately sent again, which is known as fast retransmission, because we have received 3 duplicate acknowledgements for the previous segment that we have sent. Now here we have shown the sender has sent the segment number 1, and immediately the acknowledgement for the sender for the segment 1 is initiated by the receiver for the sender. So acknowledgement is sent expecting the segment 2 to be sent by the sender, but somewhere on the way the segment 2 which has been sent is lost, and because the segment 2 is lost, then there is no other acknowledgement is initiated which shows that the segment 2 is received. And after that, suppose if the sender has sent the segment 3, the segment 4, the segment 5, then once it receives the segment 3, it understands that there is no segment 2 is received and segment 3 is received earlier than that. So it will again send an acknowledgement saying to the sender that send segment 2. Then when segment 4 is again received, again it will send the same acknowledgement expecting the second segment to be sent by the sender. Again when the segment 5 is received, it will again send the same acknowledgement expecting segment 2 to be received. Once 3 acknowledgements are received by the sender, same acknowledgement expecting the segment 2 to be sent are received by the sender, it will initiate a retransmission, because it understands that somewhere it is lost and I have received the 3 duplicate acknowledgements, so I need to reinitiate the transmission of segment 2. So retransmission occurs after 3 duplicate acknowledgements. Then possibility of congestion in network. Suppose if RTO expires, that is retransmission time out, expires, then it indicates that there is a congestion in the network and there is no segment is sent to the receiver side from the sender, or it has not been received from the receiver side. It has been sent, but it has not been received from the receiver side. If 3 duplicate acknowledgements are received, it indicates that that there may not be a congestion, or there is a weaker possibility of the congestion, because acknowledgements are coming and 3 acknowledgements are received by the sender. So it will understand that the congestion may not be there, but somewhere it is lost due to some other reason. So if RTO expires, then we should understand that there is a strong possibility of congestion. If 3 duplicate acknowledgements are received by the sender from the receiver side, then we should understand that there is a weaker possibility of congestion in the network. Then we try to understand here the whole process by using the finite state machine, and we are talking here about the sender side. Suppose if the sender is ready, then what we understand by it is ready, a chunk of bytes accepted from the process, means the process has sent some of the bytes which is needed to be sent by the sender to the receiver. Then it will make a segment of sequence number n, store a copy in the queue, and then it will try to send it to the receiver. Suppose if an error-free acknowledgement is arrived that acknowledges the segment in the front of the queue, if whatever we have sent, an acknowledgement is arrived, then it will slide the window and remove the segment from the queue, because it has already been sent and the acknowledgement has been received, and again restart the timer. Suppose if a duplicate acknowledgement is arrived, then it will try to increase the duplicate number with 1. So it will keep on doing like this unless and until the duplicate number is equal to 3. So when the acknowledgement duplicate number is equal to 3, it resends the segment. It again resends the segment which was stored in the queue. So it will try to resend the segment which was stored in the queue and again set the duplicate number equal to 0. So this is one of the scenario. Suppose if a corrupted acknowledgement is received, so it understands that it is a corrupted acknowledgement, then it will discard it. Then if there is a time out, that is RTO is expired, then it will understand that this the segment is not received by the receiver, then it will resend the same segment which is stored in the queue and then reset the timer. So this is when everything is in the ready state. Suppose if your buffer is full, if the window is full, then if it is full, true, then it will go into the blocking stage, means the next segments cannot be taken into the buffer or the queue. If it is false, then it will go to the ready state and it will try to send the data as usual. In the blocking state, again it will do the same thing. If timeout occurred, then it will resend the segment in the front of the queue and reset the timer. If a corrupted acknowledgement is arrived, then discard it. And if a duplicate acknowledgement is arrived, then again it will try to increase the duplicate number with 1, and once the duplicate number reaches to 3, if the 3 received acknowledgement is there with the sender, then it will resend the same segment and restart the timer. And once from this blocking, once it is in the blocking stage, once a proper acknowledgement is received and the window is when we slide the window, then there will be a space for the next data to be taken from the process to the queue. So it will again come to the, from the blocking stage, it will come to the ready stage. Thank you. We will see the next part in the next session.